Hello, everybody. You are listening to Through Time and Clades. My name is Albert,
And I'm Joan.
and wow, it's been a little while since we have recorded an episode, but we are finally back. And so, since we did not release a news episode just for April, we are going to do both April and May together, as we sometimes do, multiple months in one. We're still only going to cover four different science news stories, but each of us has picked one story for each month, so total of four stories, and two stories from each month. Since it's been quite a bit, tell me how have you been?
Oh, well, I have been busy. That's the blunt way I can say this. Since I've been working regularly at the local consignment store, making that money, um, that's really kind of rearranged my entire schedule and the way that I do things every week,
Right.
um, which has just shifted a whole bunch of other stuff. And I mean, I enjoy it. It's fun. It's an interesting experience, but definitely like for the first month, like I was having a wild time trying to figure out how to plan things and
Right.
schedule things and what to keep doing and what to just put on the sideline so I don't overwork myself, give myself time to rest, that sort of thing. But nowadays, I think I've gotten everything squared away. Of course, I do apologize in advance for anyone who's been interested in progress on Humanity of Prologue Season 2.
Hmm.
Of course, I just so happened to decide to plan a 17 episode lecture series and then surprisingly get a job. So
Right.
you
Right.
can imagine how balancing those things can be tricky. Um, but I'm not going to say that we're out of the woods yet. Um, if I can find extra time, I'll still be able to work on the episodes little by little. It's just going to be a little bit slower coming out this time around. Um, of course, at least I already mentioned when we premiered that we were not going to do the bi-weekly release dates anyway for that lecture series like we did for the original. So
Hmm. Hmm.
at least that was prepared for anyway. Um, but otherwise, we've been able to like work on our regular news episodes. Um, since I have work for about half the day, I have been able to like use my resting time to catch up on media and a lot of reading. Um, so I was finally able to watch HBO's Rome, which I had heard about for some time, which is really great. Excellent show. Um, I think I want to agree with somebody I saw on Twitter the other day who was talking about the show that even though it does skew some of the actual historical events regarding the figures concerned. The show covers the end of the late Roman Republic, so the ascension of Julius Caesar to the ascension of Caesar Augustus. Even though it does like tweak the figures involved in that to points where like it skews widely from what we have from our historical sources. Um, just the general look and vibes of the show is probably the best that I've ever seen regarding like ancient Roman history.
Hmm.
Like it's messy, it's dirty, it's gritty. You feel like you are there 2000 plus years ago. Um, so that was a really impressive show, and I got my sister involved in watching it, and she liked it so much that she rewatched it twice um, because it was just that good. And I definitely should watch it again at some point too. Um, but yeah, reading, oh my gosh. So I've been keeping track of the books that I've been reading on a special notebook that some friends gave me at the start of the year. Something I've never done before, but I know that I've had like fellow friends do to kind of like, keep track of how much I read and how many pages I read within a week or a day or so, which has been really interesting because I've been able to kind of crank out several books at once. Like in just these past 2 months alone, let me see, what have I written down here? So I read Indigenous Continent by Pekka Hamalainen, which was excellent. It covers the gradual colonization of North America by European powers and the subsequent resistance by native groups for the longest time. Um, I thought what was really fascinating about that is the thesis that while the centralized states in Central and South America were relatively easily toppled down because there were, specific leaders that could be taken out. by foreign powers, North America's nations proved especially resilient because they did not have centralized governing systems. They may have at one point, but quickly rejected them in place of more communal governing. So they've been able to kind of elude European colonists and keep basically keep their lands in place for the longest time, which was very fascinating to read. Excellent book. And then because I started getting into HBO Rome, I got on a huge ancient history kick. So I've been reading Andrew Robinson's The Indus, which covers the Harappan civilizations and what we know. A very old book from 1951 by H.D.F. Kitu, the Greeks. I read Roman Empire Story by Greg Wolfe, and then Forgotten Peoples of the Ancient World by Philip Matizak, which was especially nice. It's a short book that kind of covers groups of people discussed in histories of antiquity that are either depicted as invaders or the conquered. Maybe they get like a couple words here and there, but they're usually kind of ignored in favor of like the Greeks and the Romans or the Israelites or the Egyptians or what have you. So that was a really fascinating read. And right now, I am in a very fascinating and unique book by David Baker called The Shortest History of Sex,
Hmm.
which you look at the title and you look at the cover with these two cartoon T-Rexes humping each other and you're thinking, "Oh, what kind of nonsense is this?" But no, it's actually like a very thorough and chronological history of sexual development in vertebrate organisms and then like a complete sex and gender history of human societies up to the present and even in the near future, which I wasn't expecting, and it sounded really cool. So I immediately started reading that as soon as I found it, and I'm almost done with that. So I might be able to give more thoughts later if I decide to. But it's neat for a change. I like to read widely if my reading list has been able to give any indication of that. Um, so it's always nice to kind of fill the vacancies in my brain regarding like different topics of natural and cultural history. Um, so, I mean, rest assured, at least, even though I have more of a basic job that makes me tired at the end of the day, sometimes I'm still able to like find the energy to continue my education in a way. Uh, so, all in all, things have been pretty well, even if work on the show has been really slow. So I do apologize again for that, but hopefully, when the time is right, there will be more Humanity Prologue season two, because I definitely still like my plans for that show, and I think it'll be something special to add to the channel. But yeah, really, that's what I've been up to. What about you, my friend?
Well, first of all, it's good to hear that things are going well for you, settling into your new job, and even having time for reading. That's that's quite something. Because yeah, I guess as I've probably often lamented on the show before, reading is definitely one of those things that I wish I had more time for and just do not. So no, it's really excellent that you've managed to make it through so many books and are still going. That sounds like a really great way to spend your time. As for me, I actually do have some updates this time for once. So I have been, doing a lot of research related things in the background, and a lot of those things are still progressing, not as quickly as I'd like. That's, I guess, in many ways the nature of the of the work. It's stuff gets done when it gets done, and eventually you have something. But you have to put in that time. There's no shortcuts. Um, but anyways, stuff that I actually can update you all with about. Um, One is that I gave a talk for an online paleontology convention recently. This is the PaleoStream convention. Um, I think the second time they've done one. So I think they also did a PaleoStream convention last year. So if you're not familiar, PaleoStream is a community, an online community founded by the paleo artist Joshua Kanupe. I have known him for many years online. I've also met him in person since then, since we first met. What he does is that for quite some time during the weekends, like almost every weekend on Friday, Saturday, and Sunday, he does a live stream of himself doing paleo art. Over the years, he has really amassed kind of a big community around this weekly event. He also amassed quite a large number of paleo artworks from doing this, as you might imagine. But in any case, the community has grown big enough that he has been able to kind of run an online convention kind of centered around this community in the last couple of years, where people from the community attend talks that are relevant to paleontology and paleo art. And so this year, I was one of the people who he invited to speak at the Paleo Stream Con, as it is called. And so that was a lot of fun. I quite enjoy giving public talks, I find. It's been a little while since I've last done one of these, where it's like not just like a technical conference talk for other scientists, but kind of more general audience talk for people who just happen to be interested in the subject, whether or not they are actually researchers in the field. And if you're wondering, my talk was, of course, about the evolution of modern birds and kind of their early origins and some of the very difficult scientific questions that we are still trying to figure out regarding that. It was actually very similar, and I know you commented on this. It's actually very similar to the first episode of Dinosaurs, the second chapter that we recorded for the show, but it's much shorter. That one went over an hour, whereas this talk was only about 20 minutes. So if you want like a very condensed version of what I talked about, and also more up-to-date version, because that episode was recorded a couple years ago, you can go check out my talk, because all of the talks that were given during Paleo Stream Con this year have been uploaded on Yasha Kanupe's channel, and so they are free for anyone to go listen to. Another update I can share is that a paper that I worked on came out. So this was a paper that was primarily done by my PhD supervisor, Daniel Field, and who I still work with closely even after I've graduated. So it was a paper reviewing the fossils of birds and very bird-like dinosaurs from a rock unit called the Maastricht Formation, which extends partly into Belgium and partly into the Netherlands. And in recent years, basically, myself and colleagues have worked on several notable fossils from this formation that have given us like some really important insights into the early evolution of modern birds. And so in this paper, we essentially review kind of these important insights that we have learned from the fossils of this locality. I should add that the Maastricht Formation dates to like pretty much right at the very end of the Cretaceous. So at least the fossils of the birds that we are interested in here are like about 67 million years old, and the end of the Cretaceous ended at 66 million years old. So if you want a good picture of what was happening to birds and other life forms at the end of the Cretaceous, well, this is one of the best places to get that insight. In fact, the last stage of the late Cretaceous is called the Maastrichtian, and the reason it's called that is because it is named after this formation, the Maastricht Formation. And so it's definitely been a very important site historically for understanding kind of the end of the Cretaceous, but it's only been pretty recently that we have found, like, or at least recognized a lot of these important bird fossils. And part of the reason for that is because when you find bird fossils in the Maastricht Formation, they often don't look very impressive. They look like okay, there are these like tiny bones sticking out of the rock surface, but they're too delicate to actually like dig out completely from the rock, and so you just have this block of rock sitting there that has these like very dirty looking bones sticking out of it. It doesn't look like something that you would want to display in a museum for people to see and such. But now that we have CT scanning technologies, we can actually look inside the rock to get some better understanding of what the complete bones look like when we find specimens like this. And it turns out that when we have done this with these bird fossils, we have sometimes found some extremely important finds. I've talked multiple times about Asteriornis, one of the oldest known modern birds and one of the few known from the late Cretaceous. Like, that thing has a nearly complete skull preserved, but you wouldn't be able to tell that from just looking at what is exposed of the bone on the surface of the rock. So basically this combination of CT scanning technology and just, more of us being interested in bird fossils in general has really kind of helped leverage a lot of this new information out of the Maastricht Formation, even though the Maastricht Formation has had a very long history of study, or like over 100 years. And so that's kind of what the main topic of our review paper is about. We actually do present some new information in the paper as well. So a lot of time review papers are what they say on the tin. Basically, they're a review of previous information, and they're not really about like presenting new information themselves. It's just kind of a nice go-to resource for people to go to if they're interested in this topic, and say so they don't have to read like 100 papers. They can just read like this one paper and see like what the other 100 papers about this topic have said, which is a very useful role that they have. But we also use the opportunity to present a bit of new information in this paper, which is that we have some information about the age, like the growth stage of the Asteriornis specimen that we have, which we only have one specimen of. We have done some histological work. This was primarily done by our co-author on this paper, Sarah Werning. She's an expert in like studying the growth stages and growth processes of extinct animals. And it turns out that the Asteriornis specimen is probably an adult or pretty close to being an adult. So it's almost finished growing. It's probably not going to be growing much bigger than it is, which is pretty important for us to know because one of the things that we mentioned in the original Asteriornis paper was that, oh, this is a really small bird. Like it's much smaller than a domestic duck or a domestic chicken today. And so this seems to suggest that, the chicken-like and duck-like birds might have come from much smaller ancestors, and probably it was these small ancestors that made it through the end Cretaceous mass extinction. And so this kind of confirms that because it shows that Asteriornis wasn't small because it was a juvenile specimen. It really seems to have been that small, even as an adult. And so that's some new information that we have in the paper. So that's pretty cool. And I would say those two are probably my main updates that are at least relevant to the show. And we will definitely be putting links up to both my talk and the new paper in the description. But you don't have anything more to add. I think that's probably about it for updates here.
Yeah. No, it's always nice to hear, what's new in the world of paleo and our contributions to that sort of thing. I know in terms of the pop culture sphere, we've gotten a lot of really exciting news that we felt was appropriate to share with you all today. I know it's a tradition here on Through Time and Clades to let y'all know when new pop culture things emerge in the world of natural history, especially paleo. So we've been introducing a lot of like new paleo documentaries and paleo adjacent series. Yeah. Over the last couple of news episodes. And so we got two announcements recently that we want to share with you all. So if we move to the next slide, we can talk about that. So yeah, Walking with Dinosaurs is back. That's pretty exciting. Yeah. So this is going to be a joint BBC and PBS production. So I presume it'll have a premiere in the UK on BBC, and then it'll hop on over to PBS here in the States. So just like the original Walking with Dinosaurs from 1999, this is a 6-part series, but we're getting hour-long episodes this time. So there'll be a lot more content in that regard. Now, according to Dr. Thomas Holtz, who is the technical advisor, as he was in the original series, this show is supposed to be in a format more like the Ballad of Big Al than the original series. It's going to follow active dig sites in each episode, like an active dig site. And it's not expected to follow the format of the original series where you had like 1 Triassic episode, 2 Jurassic, and 3 Cretaceous. So I guess in technical terms, this is more of a second season. So this is not a remake. This is not a reboot. This is, I guess, the next step or the next stage in the Walking with Dinosaurs canon. And I guess they're supposed to be talking heads this time around.
Yeah.
In some way, I don't know if they're going to be like interspersed in the episodes, or if they'll be like at the beginning or at the end, or like in little intermission parts. So I guess that remains to be seen. Now I'm sure we're all curious, like, okay, well, what animals are we going to feature? Are we going to see the return of our favorites? It's like, well, perhaps, but there's going to be a lot of new ones for sure. So all I know is that the Hell Creek gang is going to return. We're going to have a Triceratops and T-Rex episode. Um, we have a Spinosaurus episode, the late Cretaceous of Morocco. Should be interesting. Um, we're going to have a Lucititan episode in the late Jurassic of Portugal. So Lucititan is a sauropod dinosaur. Um, you might remember Dinosaur Revolution featured the late Jurassic of Portugal as one of their episodes. In that case, featuring a Allosaurus and a is it Dinerosaurus? Am I pronouncing that right?
Dinerosaurus,
Dinerosaurus?
I think.
Dinero, yeah. Lucititan featured in that one too. That was a big brachiosaur. So I guess Lucititans is the star this time around, which is going to be interesting. And then there's also word that Gastonia and Utah Raptor are going to show up too for the early Cretaceous of Utah. Of course, Utah Raptor featured in the original series.
Yep.
A very alluring design for the animal, even though for budgetary reasons and among other things, it was nude in 1999. So I have no doubt that it'll be nice and fluffy this time around. Now, of course, I know design-wise, don't expect all the color schemes and things to return for this series. All the animals are going to have new, updated looks. So I guess that's an important note. Now, more information is supposed to be revealed over the course of the year because we have a 2025 release date, but we don't know when in 2025. They've already been working on this series for like a couple of years now, so we only just had the public announcement like a week ago or so, 2 weeks, as of the time of this recording. So no doubt if we get more information, we will dispense that as well on our program, but I think that should be pretty exciting. I mean, what's really fun for me is that the original Walking with Dinosaurs, again, 1999, this is many decades ago now. People who grew up with that show are now like working on and contributing to this second season, which is just like amazing to me. Talk about a full circle journey.
Yeah.
But that original series is classic. I rewatched it recently when I had the dinosaur bicentennial celebration while I was dog sitting, and I can rewatch it many more times, and it's still great. It was just a unique piece of media at the time. It was fresh, and it's still nice, and it's still quotable, and there's still a lot to like about it. And I'm happy that this franchise, I guess, if you will, because there's been many spin-offs in all sorts of directions, still has some breathing room. I think if you ask many, if not most folks in the paleosphere, they'll tell you that Walking with Dinosaurs, the original, was like the gold standard. It's like one of the best that has ever been made, and it has rarely been topped by similar media. Of course, that remains to be seen in the decades to come, because obviously Prehistoric Planet seemed to have really been a big boost for a lot of people too, and that's still an amazing show. But otherwise, we also got news from Netflix. So you might remember we've talked about Life on Our Planet before. This was a wider paleontology series that premiered last year that covered the whole history of the Earth and had an interesting format where there were segments featuring fossil animals and plants interspersed with footage of modern wildlife. So it was very much a back and forth retrospective on life on our planet. Of course, narrated by Morgan Freeman and executive produced by Steven Spielberg. Well, the whole crew is coming back, and they're doing a season 2 as well, the so-called next iteration of Life on Our Planet. And as with Walking with Dinosaurs, we're getting the dinosaur theme this time around. We're getting 4 episodes compared to the original's 8 that will apparently feature the story of dinosaur evolution as its primary focus instead of the wider biological world of the original series. We've just gotten like bare minimum information. We have no release date. We have no knowledge yet about what animals are going to be featured or what stories they're going to tell or even how far they're going to commit to the dinosaur story, right? Are we going to get a Dinosaurs the Second Chapter episode, this sort of thing? Because I wouldn't be surprised if we didn't, because the original Luke kind of already covered that. They had a whole bird episode, and they explicitly tied it to dinosaur evolution in a really nice way, which I appreciated seeing. So I don't know how much more they will add to this. The only thing I can certainly hope is that maybe they'll actually make some new models for a change instead of recycling Jurassic World's IPs. But hey, I understand how these things work with budget. Um, Now, I do know that this particular show has just been greenlit, hence why we haven't gotten any further information. So we might have some time before we hear back from this again. But I mean, it's been about a year. I still really like life on our planet, and I do hope that this is also something that's special, or at least helps introduce more people to dinosaur paleontology. Um, but hey, either way, paleo content is paleo content, and I'm certainly here for it. Um, of course, we wanted to highlight these two, but I know there's other projects that have been announced. I guess there's a T-Rex movie
Yeah.
that is coming to like a bunch of museums, and the museums are going to have like their own versions that feature like their collections in the film. So like if you go to different museums, like the movie will be different with each showing, which is kind of neat. Um, and of course, we're getting Jurassic World 4. We're getting the next trilogy because it's popular, and apparently they're going to return to form by having people stranded on an island with dinosaurs. So um, no surprise there. It's always islands, right? What about a freaking airport full of dinosaurs? Something new for a change. Freaking mall. But whatever. But yeah, definitely Walking with Dinosaurs and Life on Our Planet. I'm especially excited for. What do you think, Albert?
Yeah, I mean, these are very exciting. I'm definitely excited and intrigued to see what they do with the new Walking with Dinosaurs. And I've definitely heard enough to not expect it to be some kind of repeat of the original or anything like that. I think we definitely should not be going in with that mindset. But yeah, I'm interested to see what they actually do. And considering some of the people and groups attached to it, I think we can have reasonably optimistic hopes for this. And yeah, Life on Our Planet having a dinosaur spin-off, that was pretty interesting too. I'll be honest, I still have not seen the original. But I mean, paleo content is paleo content. I think it is pretty nice that there are these like reasonably high profile paleo documentaries out there being greenlit and being made. It seems like we're really going to get a new wave of these, much like we did in the early 2000s after the original Walking with Dinosaurs came out. So, yeah, I'm definitely interested to see what they do there too. And I look forward to hearing more news about these.
Oh, absolutely. I will comment though just briefly because I always chuckle at this. The announcement with Walking with Dinosaurs came with like a small promotional video that just kind of showed the logo like emerging from dirt with a bunch of like fossils and stuff
Mm,
as well. Very, very basic, no like footage of actual animals or anything in the show.
right.
I got like PTSD flashbacks to Mankind, the Story of All of Us,
Oh, yeah.
which was a History Channel documentary series. Um, and Without getting too deep into it, I have a lot of thoughts about that one. It's not great. It's given me headaches watching it because apparently the best way to talk about world history according to the History Channel at that time was to just put a bunch of flashes in your episodes of like jump cuts and scenes that just scramble my brains as I'm watching it.
Right,
Um,
right.
Freaking, I don't know if I got like a photosensitive thing going on, but like, the opening to that series is very much like this trailer did with Walking with Dinosaurs. So a small part of me was like, oh god. But no, rest assured, I'm sure this is going to be like miles, kilometers ahead of of that. Um, so I was just thinking about that.
Right,
Um,
right.
but no, I'm definitely excited about it, and I mean, 2025. It seems like a long time to wait, but also not really. Yeah, and like the way that my work schedule has been going, like some weeks just fly by.
Yeah.
Like I still feel like we're in last weekend, not this weekend. I'm like, wait a minute, wasn't I just here?
Right.
Um, but no, it's gonna be fun for sure. Um, Everybody loves dinosaurs, and I'm sure these are going to be very big. I have no doubt about it. But yeah, so that's it for our just overall updates. So I think I have first dibs. We go to the next slide. So this is my April story, and this concerns an interesting development in the anthropology of pre-colonial Australia. This is by Sean Ullman colleagues. It's always nice to get anthropology news for a change, and this was really exciting to me. So, in all the reports and ethnographies by Europeans on First Nations peoples in Australia, not once was there any evidence of pottery, whether production or use, on the continent. And the same holds true for the archaeological record as far back as it has gone. Technically, we do have evidence on the Torres Strait Islands dating to between 2600 and 1500 years ago, but the indigenous peoples there are considered distinct from Aboriginal Australians, and besides are associated with cultures in New Guinea, as well as the Lapita cultural complex, who are considered the ancestors of the Polynesian peoples, and would have sailed and interacted with the Melanesian communities there. And then in later times, maybe 400 years ago, the Macassan people of Sulawesi are known to have traveled and traded on the northern Australian coastlines, and they introduced pottery through trade, but otherwise localized production of pottery by indigenous Australians had not been known. And so there's been a question that's perplexed archaeologists in particular, whether the Lapita people ever sailed or influenced people on the Australian continent, considering that they had sailed and settled so close by to begin with. In his 1994 book, The Future Eaters, Tim Flannery pondered this question and argued that there may have been some brief contact involved between the Lapita and the continent, and mainly his argument stems from the case of the dingo, which has been no stranger to this show. Their question of origins into Australia has been pondered just as heavily, and there's been many hypotheses which we've talked about before. For Flannery, it was as simple as the dingo being an import from the Lapita peoples, where they had been previously utilized as a food source. And looking at the DNA evidence, there does seem to be some support as well for this. I mean, the genes of Polynesian dogs that we still have and dingoes seem to converge from a common ancestor that lived in southern China, which is also where the distant ancestors of the Lapita peoples lived before becoming maritime peoples. So if the Lapita may have been the ones to introduce the dingo, well, then why didn't they also introduce pottery? Well, maybe they did after all. So Anjiguru, known as Lizard Island to Europeans, located on the Great Barrier Reef in northeast Australia, archaeologists in 2006 discovered shards of pottery on the surface of the island that had been so worn down and damaged that dating techniques couldn't work. But their composition at least seemed to indicate that they were locally made, and that was particularly enticing. In more recent times, Sean Ulm's team have reported more pottery shards, and this time from within a sizable midden, measuring 195 centimeters or almost 2 meters thick, that had been previously dated to within the time period of the later Lapita complex and then the immediate time afterward. There were 82 fragmented pottery shards of various sizes and shapes that were interspersed with shellfish remains. But unfortunately, they were all so broken that any attempt to reconstruct the outline and shape of the whole pots was not going to happen anytime soon. But there were some interesting clues to their appearance. For one, on some of the pieces, there appeared to be lip tips. And these are incised lines in a parallel diagonal pattern. And for another, 2 or 3 of the shards have remains of red slip, which is a red-orange paste that is used for painting the outside of a pot. So these incensed lines and red slip are classic aspects of Lapita pottery, found in much better remains in the Western Pacific. So their presence here suggests a link of some sort. And that's where things get really interesting. The temper was found to be composed of sand and other minerals that were consistent with a localized origin, Anjiguru, again, with further support from geochemical studies. And thankfully, the dating of the pottery shards was more promising this time around. According to the radiocarbon analysis, as well as a Bayesian modeling, the pottery shards were deposited in the midden during two time intervals, during the time that also overlaps with Lapita production of pottery in New Guinea. So the first was between 2,950 and 2,545 years ago, and the second was 1,970 to 1,815 years ago. Now, Jiguru was first populated by First Nations Australians around 6,510 years ago, and has occasionally remained so ever since, according to later archaeological and then ethnographic records. But during the time of the pottery layers, the Lapita and their descendants had already settled widely in New Guinea and were as far west as Tonga and Samoa. And even on some of those islands, pottery making had ceased. And so the team's interpretation and implications of all these results are as such. Given the widespread evidence of a Lapita-inspired interaction sphere between eastern New Guinea and the western Pacific Islands, it seems that Jiguru and its peoples were involved in this in some way. The designs and pigment on the pottery fragments and their dating represent a clear link with other pottery types within the Lapita complex, which suggests that its presence here was due to diffusion through exchange networks between First Nations Australians and them. However, that they were locally produced based on the mineral types shows that it was more likely the practice of pottery making that was introduced by the Lapita, and then its subsequent production was a local indigenous development. And this is supported by the fact that Lapita peoples rarely traded whole pots in their networks. In all the sites where we find Lapita pottery, where non-Lapita peoples are inhabiting, even though they're using Lapita methods, they're all tend to be made with local materials. And so further investigation has revealed that for all the many pottery shards that were found, the people of Jiguru do not seem to have made very many pots with these materials. And the fact that they were very thinly walled in structure suggests that they were not used for cooking everyday meals. But as to what else they would have been used for, the team was not really sure. And so that opens up a possibility for further analyses. Now, I briefly mentioned that Jiguru was occasionally occupied over the last 6,500 years or so. And that's because archaeological and ethnographic records suggests that First Nations peoples likely never permanently settled on this island, and it was used as a seasonal territory by groups who lived on the coast. And that's an interesting case. Boat use by Aboriginal peoples is well documented. In fact, it's almost consensus now that this was the method that people used to first populate that continent. So coastal Australians would probably have felt right at home within the interaction sphere, which the team argues belonged to the Coral Sea interaction sphere, as per Ian J. McNiven et al.'s 2021 paper. Now, the paper here includes a very handy map, which I've posted here to the left, which shows the extent of this cultural and political exchange network, which includes New Guinea and its easternmost islands, and involves trade in both marine and terrestrial items and goods. And the archaeological work at Jiguru may only be the first line of evidence that perhaps many of Australia's northeast islands were involved in this too, and may even have pottery shards preserved as well, which again would only further change the deep history of the First Nations peoples on the continent. And so, to kind of see evidence of this technological use in peoples where it had never really been known before was just mind-boggling and fascinating to me, and I knew I had to talk about it and introduce it on this show. So Albert, I'd love to hear your thoughts on this paper.
This is, I would say, like, this is a topic that I was not really familiar with. I feel like it's not something that most of us who aren't into archaeology or anthropology pay that much attention to. It's like it kind of feels a lot of the time like the stereotypical idea of what do archaeologists study? Well, like pottery seems like a pretty universal thing, right? You just kind of assume that most cultures have had it at some point or another. Um, but evidently that's not the case. And it's really interesting that that not only did they find evidence of pottery where there used to not be any, but the idea that it was not acquired through direct trading, but instead through, I guess, cultural inspiration almost. That is a really tantalizing and evocative thought. But it really is one of the things that characterizes humans, right? That we take inspiration from others and kind of adapt things that we like about how other people do things. So it's really cool to get this kind of record. You do have to wonder, like, what were they doing with the pottery, like in this on this island? It really does stimulate the imagination. I really hope that they managed to find more complete records of whatever objects they were making with this pottery, because it would be fascinating to find out exactly what was going on here. I think that's a really good first story that you picked here.
Well, thank you. Yeah. And I think it's important also to address with this paper, because obviously, when you look at the history of ethnography, which I've addressed to an extent in our first episode of season 2 of Humanity: A Prologue, because European ethnographers were not finding pots among First Nations Australians,
Mhm.
there was implications then that, oh well, these people just were not technologically advanced enough.
Right.
They were very primitive, unlike other peoples who were making very beautiful pottery. Um, but that does not mean then that with this study suddenly, oh well, these people are actually more technologically advanced
Right.
than we
Right.
thought. It's like, no, well, first off, that's a completely flawed way of looking at this. Um, People devise technologies by necessity.
Mhm.
If you
Mhm.
don't if you don't need pots, and if you can't use pots, well then you won't invent pots,
Mhm.
right? I mean, we have ample evidence that First Nations peoples were making baskets and containers and purses out of more fragile materials, plant matter, that doesn't necessarily preserve very well in the archaeological record. And they were probably doing this from the very beginning before there were even people on the continent. They probably brought that technology over with them.
Mhm.
And for groups that were, primarily nomadic for great swaths of the continent, it doesn't really make much sense to carry on these big, heavy pots when you can just weave a basket and carry what you need and put it over your shoulder, and it's much more lightweight and flexible and manageable.
Mhm.
You don't need to, worry about pots. And so I think it's important to recognize that just because a society at any time in history lacks a certain technology or process for making a technology or using materials in their environment, um, that it's necessarily a sign of greater or lesser intelligence.
Mhm.
People everywhere are pretty much capable of the exact same thought processes and technologies and capabilities. It's just a matter of what the culture and environment allows for them to use. If I'm explaining that properly. Um, so the fact that we see this pottery use among First Nations Australians is big because we've never seen it before. But I wouldn't. I would hope that nobody would take it beyond that to say that this is somehow evidence of more sophistication in
Mhm.
technology than it was already there. I mean, if you read about First Nations peoples in the ethnographic records that we have, well, there was plenty of sophistication there. You don't have to worry about pottery changing things like that. you know, but of course, it's also just neat to see more evidence as well of this connection with the wider Pacific world. Again, there's another kind of myth that Australia was just once it was populated, it was like completely out of the rest of humanity's affairs until Europeans showed up. No, clearly, like there were areas of the continent that were in close contact with other regions. I mean, clearly, New Guinea, uh, being so close, probably had a similar cultural ancestry to that region. Um, and through that means, like with the Lapita people, they were also connected to the wider Southeast Asian world, and then subsequently into mainland Eurasia. And so, in many ways, no, Australia was not isolated for so long, and it was receptive to outside influences as well. I mean, the dingo obviously would have proved that, but clearly with this wider engagement with an interaction sphere that had been going for over 2,000 years, almost 3,000 years. Um, yeah, I mean that checks out for sure. Um, it might be time to consider Australia part of a wider Pacific network than it has usually been given privy to in the deep past. So, yeah, I definitely really wanted to share this paper, and I'd love to see where the research goes from here and just how far and how extensive this network truly was. So that's all that I have to say about this paper. Albert, would you like to go on and do your April story?
Alrighty then. So, for my April story, we're going to talk about phylogeny again, which is a very common topic on the show, but what can I say? It's one of my favorite subjects, and it's also one of the main topics that I research. So, um, I think if you come into this show, you're going to hear a lot about phylogeny. Um, and so, this is quite an interesting study that I came across. What this paper is about is essentially um, kind of figuring out how to address the impact of growth in organisms or ontogeny, so how an organism grows from a juvenile to an adult, in phylogenetic analyses, which is quite an interesting problem that we have. So, of course, when we study living organisms, most of the time we have a lot of genetic data that we can work with. And so the majority of phylogenetic analyses on living organisms nowadays is focused on analyzing genetic data, and that's given us a lot of information about how organisms are related to each other and how they've evolved. However, for those of us who work on organisms that are extinct, we often do not have that luxury, especially if we work on organisms that are older than, say, a couple million years or so. DNA most of the time simply does not preserve that long, and so we do not have genetic data to work with, or even if we might have a little, it's not really enough to reconstruct phylogenetic relationships reliably. So, most of the time when we study the relationships of long extinct organisms, we have to rely on anatomical data or morphology. So, what the organism looks like and the actual shape of like its anatomical features. Um, and here we can kind of run into an issue. So the way that we do anatomical phylogenetic analyses is collect a lot of data on the anatomy of all these different organisms that we're interested in, and then we kind of represent that in a what we call a data matrix. So the data matrix has data on all these different species that we want to analyze the relationships of, and also their anatomical characteristics or characters. Um, and so we'll indicate in this data matrix, does this organism have teeth or not? If it has teeth, are they sharp or are they blunt? These are just examples. In real life, oftentimes characters can be more complex than that. And if it has teeth, does it only have teeth at the front of its jaw or only in the back, or does it have teeth all along the entire length of its jaw? Things like that. And we indicate all these things in the data matrix. And then we analyze them using computer programs, and it'll use the information we provided based on these organisms' anatomy to try and group together what is the most likely relationships, phylogenetic relationships, which organisms are most closely related to each other based on the data. Um, and so that can be all well and good, but we do have an issue when we are scoring or kind of collecting anatomical data from extinct organisms, and that is not all similarities or differences in anatomy are because of phylogenetic relationships. And one of the main kind of sources of differences in anatomy is actually the process of growth in organisms. Like, think about it. Like a baby human does not look like an adult, right? There are plenty of differences that happen during the process of growth, and so if you score, say, a juvenile human into a data matrix and an adult into the same data matrix, you're not necessarily guaranteed to find them as close relatives in your analysis, even though logically that should be the case. I mean, they're the same species. You should find them as forming a group together to anything that's not a human. Um, but that can be a real confounding factor when we're studying extinct organisms, especially because with extinct organisms, we can't just keep one or observe one out in the wild and then see how it grows up. Like you can't. So sometimes we might only know from juvenile specimens, and then in other cases we might only have adult specimens, and it's possible that they are actually the same species or closely related species. And when we run a phylogenetic analysis, where it is assumed that all these differences are down to kind of phylogenetic relationship, that can kind of throw a real wrench in the results and make them kind of unreliable. This big study that came out in April tried to address this problem, specifically using Mesozoic theropods. And so the author of this paper, so there's only one author on this paper, Andrea Cao, he's an Italian paleontologist who specializes in the phylogeny of Mesozoic theropods. The theropods are, of course, a group of dinosaurs that includes pretty much all the meat-eating dinosaurs, but it also includes some species that don't eat meat. And notably, it also includes birds. So theropods are still alive today. But in Andrea Cao's research, he mostly focuses on the Mesozoic theropods. So that includes some types of birds, but not the species that we have alive today. And Andrea Cao has been thinking about this problem for a long time. So he has published previous papers like discussing kind of the possibility that ontogeny is kind of messing up our understanding of Mesozoic theropod phylogeny. And in this paper, he basically presented what he considers to be a new method to address this problem. And so to understand this method, you have to kind of know how we usually try to address the problem of phylogeny or the problem of ontogeny in extinct animal groups. And so that's basically what this figure on here is trying to show. So in letter A is basically a representation of a data matrix and how you would usually address ontogeny in a typical phylogenetic study, or what has been done, at least in previous studies. So in the data matrix here, you have a taxon A on top. So you see this is one species of theropod for which we know of adult specimens in pink and juvenile specimens in blue. So a much smaller blue silhouette is a juvenile of the big pink one. And in cases like this, oftentimes people will say, okay, well, we're just going to ignore the juveniles, and it doesn't matter what the juvenile characteristics are like. So we're only going to score the adult characteristics in this data matrix. And so you can see here that you have 4 different characters that are included in this data matrix for the species, and they're all in pink, so they all represent characters from the adult, even though we have juvenile specimens. But it's just like, but the ontogeny can mess things up, so we're going to ignore that. We're only going to consider the adult. Okay, that's one way to do it, but if you think about it, that can be problematic, right? Because who's to say that the juveniles don't have informative characteristics about phylogeny? That's not something we can assume beforehand. Maybe the juvenile characteristics will actually help us place this species in the phylogeny. But if we don't include the juvenile characteristics, we can't really get a sense of that, right? So yeah, there's a bit of a problem here because we're kind of leaving out information that might be relevant just because the ontogeny might mess things up. Another possibility is to say that, well, say this is an instance in taxon C, for example, where we only have juvenile specimens known. So in taxon C, you can see there's only a small blue silhouette with no big adult accompanying it. So we only have a juvenile known. And so we can score this juvenile specimen for some characters, but in cases like this, we'll say, because we can identify this as a juvenile of something, even if we might not have the adult specimens, we're going to ignore some of the characters that it has because these are quote-unquote juvenile characteristics. We know these are going to change when it grows older, or at least we have a good reason to suspect that it will, and so we're going to leave some of these characters out. And that's what the exclamation mark here on taxon C is supposed to represent, is that we know it has these characters, but we're going to ignore that because this is a juvenile specimen. And again, you can see the problem here is that we're leaving out information. And just because it's going to change when it grows older, that doesn't mean that's not relevant for understanding how it fits evolutionarily. And so these are kind of the potential solutions people have tried in previous studies. But as Andrea Cal points out, this is not ideal. And so what he has presented here is a new method to analyze these data matrices, but include both juvenile and adult characteristics. And his idea is represented by the letter B here. So say you have, again, a taxon A where we know both juveniles and adults. Well, then for the same character, we kind of score them for an adult state and a juvenile state. So for example, character 1, we can score what it is like an adult, but then we make a separate character, even though it's referring to the same feature, and then score what it looks like in a juvenile. And we do that for all the characters that we can score for this species. Whereas if it's a case like taxon B here, where we only have an adult specimen, we can simply score the juvenile characters as unknown. And then in a case where, like taxon C, where we only have juvenile specimen, we'll score the adult states as unknown, but only score the juveniles. And so this way, we are not leaving out any of the information that we have in these specimens. We have the states in the juvenile, and we have the states in the adult. And so we can take into account all the information that we have. And you might say, well, this raises its own problems, right? And so one of these things is that a lot of these changes during growth are not instantaneous. You don't just suddenly kind of transform suddenly into having all of your adult features at once instantaneously. That's not how growth works in most types of vertebrates, at least. And so what do you do with that? And so this is what Andrea Cao is representing here at the bottom of the figure. Specifically, I think it's probably easiest to tell in the bottom right here. So say you have like a whole series of growth stages, like a very young juvenile to an adult and everything in between. So that's what semaphoront A to F are supposed to represent here. Semaphoront basically means growth stage. What you can do here is that based on having this really complete growth stage, you can identify what are quote-unquote adult features and what are juvenile features. So what are things that change towards the path to adulthood? So say in a slightly older juvenile, like semaphoront B, it might only have one feature that is kind of resembling the adult. And so for that, you can score it as being an adult feature, even though this is a juvenile individual. For its other features, you can score it as having juvenile features, and so on and so forth. And so in this way, you're not repeating kind of the same feature over and over again in this analysis. So like you're not saying that just because this feature is in a juvenile individual, you're going to score it as an adult feature in the data set. You're basically kind of parsing this out based on what we know about the growth of these animals. And so redundancy of the characters is removed. So yeah, I think it's pretty good that he considered that and took that into account. So it is important to emphasize here that when this paper is talking about scoring juvenile characteristics in these phylogenetic data sets, it doesn't mean that any feature found in a juvenile specimen is a juvenile feature. Rather, it means these are features that are retained in juveniles until they get changed in adults, basically. Okay, so that's a bit complicated. The phylogeny can be a little complicated, but that's a general gist of what the method is. What did Andrea Cao find when he applied this data set to kind of studying Mesozoic theropod phylogeny? For comparison's sake, what he did was that he first ran an analysis where he didn't do this kind of separating of the adult and juvenile feature, quote unquote, a normal way you would run a data set of this kind, where there's no distinguishing of these features. And then he ran it again, but kind of did the separation. And it turns out that there were some pretty interesting differences between the two results. And one of the biggest kind of differences is that there's this group of theropods that have traditionally been called Compsognathids. So these are mostly small theropods, and they're small theropods of the meat-eating sort, and they have pretty generalized features, to be honest. Like a lot of them have a long tail. They often have moderately short arms, pretty relatively big heads for their size, so they have big eyes. And traditionally, in most of the previous studies, it has been thought that a bunch of these small theropods of this general body form were close relatives, and they were all united in the group Compsognathidae, and so they were all called Compsognathids, which is named after the genus Compsognathus from the late Jurassic of Germany, from roughly the same time and place as the early bird-like theropod Archaeopteryx. And in addition to Compsognathus, there are a bunch of other species that have been referred to this group, so things like Sciurumimus, also from the late Jurassic of Germany, Scipionix, from the early Cretaceous of Italy, Juravenator, another German late Jurassic form, and several different species from the early Cretaceous of China, Sinosauropteryx, Sinocalliopteryx, and Huashonathus. And it turns out that without this ontogenetic kind of splitting of the characters, all of these species did indeed get recovered as kind of close relatives of each other. So you found kind of like this traditional group of Compsognathids, quote unquote. And specifically, Compsognathids are usually found as a group of Coelurosaurs. So they would be close relatives of things like Tyrannosauroids and Ornithomimosaurs, and also Maniraptoran theropods, including birds. And not so closely related to things like Allosaurids or Megalosauroids or Ceratosaurs. When Andrea Cao did this ontogenetic splitting of the characters, it turns out that the group Compsognathidae kind of broke down, and the Compsognathid specimens were found like all over the place in theropods, not just Coelurosaurs. And so, for example, in this particular study, at least, he found that when the ontogenetic characters were taken into consideration, Compsognathus, Sciurumimus, and Scipionix came out as megalosauroids and not Coelurosaurs. And specifically, Scipionix was recovered as a juvenile Spinosaurid, which is really interesting, because Spinosaurid adults, at least, have this very distinctive morphology where they have like this very long kind of crocodile-like snout, and they're thought to have been sort of semi-aquatic in their habits. They were feeding a lot on fish and such, and we have direct evidence of this from stomach contents too. But Scipionix does not have like a big long snout like that. Very interesting. Juravenator was found as an Allosauroid, whereas Sinosauropteryx, Sinocalliopteryx, and Huashonathus, the three Chinese forms, they were found as Coelurosaurs, but not members of like any specific Coelurosaur clade. Like they weren't found as Tyrannosaurs or Maniraptorans or anything like that. So they're kind of just like early diverging Coelurosaurs, and it's not clear if they all form a group together or not. What does this suggest? Well, finding these Compsognathids grouping with things like Allosauroids and Megalosauroids, including Spinosaurids, suggests that they might actually represent the juvenile specimens of these much bigger, kind of larger carnivorous theropods, which is really interesting because otherwise we haven't really had many good specimens of juveniles of these groups. And so where are the juvenile specimens? Well, it's possible that we've been looking at them this whole time. It's just that we didn't recognize them as juvenile Allosauroids or Spinosaurids or whatever. And instead that these small theropods that were found from similar times would grow up to become like these apex predators in these environments, which is quite fascinating. And this is not a completely new idea because in a previous study, Andrea Cao did already kind of suggest the possibility that many of these specimens were probably kind of juveniles of these bigger theropods. And even earlier than that, like in the original description of Sciurumimus, it was suggested to be like a juvenile megalosauroid. And it was later disputed by other studies that found it as a Coelurosaur and specifically Compsognathid. But these aren't entirely new ideas, but it's interesting that putting this new method into play kind of gave us more support for this. There have been quite a number of reactions to this paper, not so much in the scientific community just yet because it's such a new study. Like people haven't really had the opportunity to really like dig into the data in detail and write up their own conclusions and responses to this paper. But just in general, like people who are interested in paleontology and dinosaur paleontology especially. I think people, a lot of the reactions I've seen, I think they kind of fixate on many of the individual results in this analysis. Like, is Compsognathus a megalosauroid now? Or like, wait, this particular species in this was found in a weird spot. And yeah, like yes, because this is a massive phylogenetic analysis. Like there were like something like hundreds of species in this analysis, and many of them are not known from complete specimens. Like this is just kind of the nature of the beast when we're working with anatomical phylogeny, is that when you're working with like a bunch of different taxa, and many of them are known only from incomplete fossils, you're going to get cases where weird results pop up, and some species just get found in unexpected locations in the phylogeny. And that doesn't necessarily mean like the whole thing is unreliable. It just means that we don't have enough data for many of these species. And so I don't think we should obsess over a lot of the individual results in this analysis. And even Andrea Cao himself, like on his Facebook page, I've seen him say this. Like, yeah, there are some weird results in this analysis that require further research to kind of test, but that's not really the point of this paper. I think the most important takeaway of these results is that the ontogenetic characters clearly are affecting the placement of these compsognathid, quote unquote, taxa. And so I think there is a very real possibility that we should be using these methods more to kind of identify when ontogeny might be kind of throwing a wrench into our phylogenetic results. And I do think there is at least a pretty good case to be made that, yeah, these are juveniles of bigger theropods. Whether or not they are specifically allosauroids or megalosauroids or whatever, I think that can be up for debate in future research. But it is really not such a crazy idea because many of these specimens, it has long been recognized that they are clearly juvenile individuals, like things like Scipionix and Sciurumimus. Like they're clearly like babies. Like I mentioned earlier that they have like these big heads with big eyes and such. And yeah, like those are juvenile features. Like so, how big would they have gotten when they were adult? Like we don't really know unless we find like a clear adult in the same time and place from where they are found. So yeah, like I don't think this is a crazy idea. I don't think I don't think like we should be too attached to this very specific results of where these species are placed. But the general idea that we need to take into account the ontogeny and that ontogeny has been affecting our understanding of the evolution of these compsognathid taxa. It's an idea that's provocative, but it's very much worth considering, I feel. And I think that this study makes a pretty good case for that. And something else to keep in mind is that when we decide what characters are juvenile characters and what characters are adult characters, that is based on like having known growth series of these taxa, right? Or at least of theropods in general. So, for example, we have pretty good growth series for some types of ceratosaurs. We have decent growth series for some types of tyrannosauroids and such. And so when we decide what characters are juvenile characteristics in theropods in general, a lot of time is based on like these few species for which we have like confirmed growth stages. It is possible that if in the future we get more information on the growth process of many of these groups, then we might have some changes in the understanding of what we consider to be a juvenile characteristic or an adult characteristic. And that in turn is going to affect the results of the phylogenetic analyses when we analyze them in this way. And so there's definitely a lot of future work that can be done based on new discoveries and such that can further refine these methods and results. Okay, final point I'm going to make is that this paper has a pretty, I would say, kind of grandiose title because it calls this study a unified framework for theropod evolution. And it's like, well, this is a pretty big study, but why is it called a unified framework? And I guess, at least based on my reading of the paper, like Andrea himself might explain this differently, but I would say it's because it takes into account all sources of morphological information to inform our understanding of theropod evolution and ecology across their entire history. And what does this mean? Well, basically, with the recognition that Compsognathus might be juveniles of megalosauroids and allosauroids and maybe some other groups, Andrea Cao also did some analyses of like the ecological composition of theropods over their evolutionary history. So, in many ecosystems, for example, where allosauroids and megalosauroids are the largest predators, we have multiple different types of large theropods coexisting with each other. But in the later half of the Cretaceous, there's an interesting kind of change in ecosystems that we observe, and that is we no longer see allosauroids and megalosauroids in the northern hemisphere as the top predators. In fact, they seem to have died out in Asia and North America. Instead, we start seeing the tyrannosauroids take over as the biggest predators in the region. This is where we get things like T-Rex and Tarbosaurus and other types of big tyrannosauroids is towards the end of the Cretaceous. It's only then, after the extinction, these local extinction of the megalosauroids and allosauroids, that they kind of become the apex predators. And in these ecosystems, these quote-unquote tyrant-dominated ecosystems, which the in this paper Andrea Cao calls tyrannies, in these tyranny ecosystems, there often aren't any other big carnivorous theropods around. Like it's just like this one or two species of big tyrannosaurids, and that's it. That's all the top predators that there are. And oftentimes there aren't any like mid-sized theropods or these carnivorous theropods either. And so basically, based on the results from his phylogeny, Andrea Cao analyzed how these size distributions of theropods changed in these ecosystems over time. And he was able to confirm that, yeah, in tyrannies, there often aren't many mid-sized theropods. But what's kind of interesting is that it's not so much that there are fewer big theropods, but also that there are more small theropods in the tyranny ecosystems. And many of these small-bodied theropods are maniraptorans, so like the group including birds, whereas in allosauroid and megalosauroid dominated ecosystems, the small theropod diversity is much kind of lower, and you don't get so many maniraptorans running around. So what's going on here? And it's possible that it's not so much that tyrannosaurids were good at being big after the allosauroids and megalosauroids died out. But maybe maniraptorans are kind of weird in that they're not good at being big. And so it may have been that in Asia and North America, after the allosauroids and the megalosauroids died out, the maniraptorans weren't able to go into the big apex predator niche because they just weren't that good at it. And so basically only contenders left were the tyrannosaurs, and that's what happened. The tyrannosauroids became the big predators. And if this is the case, then why might this be the case? Well, maniraptorans exhibit some interesting transformations during their evolution. For example, they attain a more crouched kind of posture in the way they hold their legs. If you look at how a bird today walks, like they're oftentimes like they're basically crouching essentially, and it's often hard to tell because you can't often see a bird's knees when they're walking around like. Where you're looking at a living one, because the knee region of the leg is kind of hidden under all the feathers and such. And what you see of the exposed part of the leg is just the ankle down, or maybe a little bit of the lower leg. But if you are able to like strip off all the feathers on a bird, then you will see that the knee in a bird is usually held like basically bent pretty much all the time. And so during the evolution of maniraptorans, we start seeing the acquisition of this kind of weird walking style where the knee is mostly bent, which is quite interesting. And we're still studying like kind of exactly what the functional benefit of this might be. But it means that you're not as good at getting big, because if you want to be big, you want a leg that can support you like efficiently from underneath. So you want like a more or less straight leg, right? But if you have a mostly crouched leg, that's not as good for supporting large amount of body weight. So maybe the bird-like theropods were not good at getting big, in part because of this. There are some other ideas too. For example, we've talked about before how a lot of the bird-like theropods within the Maniraptorans incubated their eggs by sitting on them themselves and kind of using their own body heat to incubate their eggs instead of just burying them and leaving it up to the sun or to rotting vegetation to do the job. Well, if you are sitting on your own eggs, that most of the time that means you can't get too big or else you'll crush those eggs, right? And so that might be another reason that's stopping them from getting big. And of course, there's also the origin of flight, which, well, not all Maniraptorans can fly, but certainly the ones that are close to birds, we start seeing them experimenting with that. And obviously, that's usually it's usually more beneficial to be smaller and lightweight if you're a flying animal, and so well there you go. That's another constraint on their body size, and indeed. Something that I think really drives home the unified part of this unified framework is that these conclusions are not only applicable to Mesozoic theropods, because if you extend these conclusions out to the Cenozoic, where only birds are left as the only surviving group of theropods, the biggest birds that we have had in the history of Cenozoic theropods are things like elephant birds, moa, and terror birds, and also things like dromornithids, which are also called like demon ducks of doom. And all of these are like really big birds that weigh hundreds of kilograms, but none of them get over a ton. In fact, none of the Paravian Maniraptoran theropods, as far as we know, get over a ton. And this is even in like quote unquote optimal conditions, like even in say South America early in the Cenozoic. For indeed, I would say for much of the Cenozoic, where there were almost no other big predators, like they still did not get over a ton, over a few hundred kilograms. So it seems that even under conditions where they could become like the largest animals around, or at least the biggest predators around, Maniraptoran theropods just never get that big. And that stays true throughout their entire evolutionary history, from their very beginnings in the Jurassic all the way to the present day, when Maniraptoran theropods are still alive in the form of birds. And so, yeah, like this is a really interesting study, and I'm really glad that Andrea Cao did not neglect kind of taking into account the Cenozoic history of theropods. I think more studies should do that, because I think the field as it is often very segregated. Like if you study Cenozoic fossil birds, you only study that, and you often don't do much with Mesozoic theropods. And if you study Mesozoic theropods, you often only study that, and you don't do much with the Cenozoic part of theropod history. But this is kind of an artificial divide, right? There is no real separation between these groups. It's just that one happens to live before the Cretaceous and one happens to still live after the Cretaceous. And so when we consider questions in theropod evolution, I think it is important, and dinosaur evolution in general for that matter, I think it is important to take into account their entire history and not just kind of arbitrarily only think about one or the other, and see whether or not the patterns actually apply to this entire lineage. And so, yeah, quite a large scale study. And so there's a lot of detail in this study that obviously we do not have time to get into here. But if you're really interested in these topics that we've talked about today, I highly encourage you to go to the original paper. It is open access, and it will be linked, as with all of the studies we talked about, in the description below. Do you have anything to add to this?
Oh gosh, well, there's a lot to take in for sure. It's a fascinating idea for a paper. I mean, the fact of trying to incorporate juvenile specimens into a phylogenetic analyses where usually adults are prioritized, it kind of reminds me of this idea nowadays that when you want to understand an organism in their entirety, it's important to not just focus on like the male individuals, right?
Yep.
Like how this bias against like female individuals
Yes.
in analyses, for example. And so I imagine juveniles probably have gone through a similar thing
Mm-hmm.
in that instance in terms of trying to understand the diversity of the group. So seeing that incorporated here in this way, I think, is a really genius idea.
Mm-hmm.
Um, and I'd like to see this more implemented in future studies for sure. I mean, just the concept that Compsognathid may have been like an artificial group this entire time, composed of juvenile animals from across the theropod tree. I think it's interesting. It's an interesting concept, and I know obviously I don't want to focus on the individual animals or specimens as you have mentioned. Um, but I can certainly understand like where people are coming from. I guess in that instance, obviously you have people that are that outside of well, maybe not necessarily outside of like the scientific community that have attached themselves to certain animals, and so they're probably I wouldn't be surprised if they'd be shocked to find out. So wait a minute, you're telling me my favorite dinosaur is just a kid
Yeah,
of
right.
probably some other different animal? Um, so I guess like that. I mean, I imagine this would not be something that would happen right away, but there'd probably be a huge like taxonomic reshuffling in the next couple of decades if we're lucky to find more specimens of these animals, right? Like Compsognathus being, you know, an invalid name because actually the juvenile of this other animal it's already been identified. Um, that would be interesting to get used to. I mean, it certainly makes sense for sure. I had been curious because I knew some of those animals were juvenile specimens to begin with. Like Scipionyx was like the most famous baby dinosaur I
Yeah.
knew growing up. I remember when those fossils were announced. Um, I'm curious if I mean if we really want to test this idea, like how many of these so-called compsognathids have had like the bone growth studies done, right, to see like how much the bones have grown over time. I'd be curious about that.
Yeah.
Um, and then comparing that to the more complete growth stages that you mentioned for like ceratosaurs and megalosaurs, for example, um, and see if there can be comparisons there to be made to kind of show like what kind of age we're looking at
Right.
for these animals. That I'd certainly like to see. I would definitely want to look at the paper too, because I'm sure Andrea Cow probably addressed this as well. Um, I'm most intrigued about the ecosystem implications for
Mm.
this. What you just discussed, these tyrannies, right? Or tyrannies, I guess, to be more appropriate. Because I guess that would kind of lend some support to the idea that as tyrannosaurids were growing up, um, at a certain stage, the individual, like the younger juvenile individuals, are kind of taking over the so-called medium-sized predator
Right.
niche because they're the only ones that can. Because
Yeah.
everything else is either really small or is a baby that's going to lead up to that stage, and then
Right.
eventually
Right.
to the multi-ton animals. Um, so that's gets. I'm curious about that too, for sure. Um, but this is really nice, and I'd be curious to see if there are other areas of the dinosaur family tree, or even just like fossil family trees in general that show this sort of thing. Um, Obviously, like the closest thing I can think of is the reanalysis of brontotheres in
Mm.
Cenozoic mammal paleontology. How turn of the century you had like many different species of brontotheres that were being described in North America, and then further analysis has shown, oh wait a minute, a lot of these are just juveniles
Right.
or like females of this other individual too, and so that diversity has just dropped significantly. Um, yeah, definitely. I definitely want to watch this space to see um, where this goes, and I definitely want to see some more responses too. I'm sure this is not going to be the last word by any stretch. Um, and knowing Andrea Cow, he's a really prolific researcher,
Right.
so I'll be following this with close scrutiny and curiosity. Yeah, this is a really great paper. Thank you for sharing this one.
Yeah, of course.
Uh,
And yeah, I'll mention too, I'm definitely curious to see this applied to other groups of organisms. I would be very interested to see what they find. And in fact, I will say that this is actually a problem that I've had to consider myself in the past. And not just because I work on phylogeny in general, but specifically because during my master's degree, I worked on the phylogeny of crustaceans, actually. So pretty different from what I study now. Of course, crustaceans they go through massive changes in their growth. And remember that insects are technically a group of crustacean. And so if you think about the difference between a caterpillar and a butterfly, right? Those are massive
Yeah.
changes in growth. And so how do you consider that kind of thing in a morphological analysis? And that was something that when I was working on my master's degree, my supervisors they were like kind of discussing with me and thinking about how do we address this anyway? And because my master's degree was only for about a year, like I didn't have a lot of time to actually like go into a lot of these details and such. But one of the ideas that we had to try and address this was something kind of similar to what Andrea Cow did here, where we separate out the juvenile and adult characters. But I never got the chance to really put that into practice with the crustaceans. And so yeah, it is as you might imagine something that a lot of us have already been thinking about for a long time. But to see this actually apply to like this big charismatic group of animals, I think it will really help raise its profile. And yeah, definitely look forward to seeing what other people make of this method and whether they choose to apply it in the future. But yes, that's really all I had to say about this. So if we like, we can head on to your next story.
Yeah, which is also phylogeny based,
Yes, it is.
incidentally. Um, so yeah, so this is my. So now we're getting into our May stories. This is my May story, more paleontological in nature, and this comes from Valentine Buffa and colleagues. So in 2004, paleontologist Phil Center proposed and then defined a new clade to encompass some old reptiles called avicephala, or bird-headed. It includes small reptiles from the late Permian and throughout the Triassic that appear to have been mainly arboreal and had skulls with pointed snouts similar in shape to birds, hence the name. But they wouldn't have had horny beaks or anything like that. I really should stress very highly that these animals would have had nothing to do with birds. Birds are
Yes.
Maniraptor and Coelurosauran theropod dinosaurs, and the evidence for that is overwhelming, as Albert will tell you. Now, there have been proposals in the past and in recent times by a few fringe researchers and cranks, but these have not been supported by the data. So, right away, these are not dinosaurs, nothing to do with birds. These are kind of their own thing. The roster of Avicephala includes three branches of now extinct reptiles. And the first is Longosquama insignis from the mid to late Triassic of Kyrgyzstan. Probably one of the most contested and mysterious fossil species we know about. There's only been one skeleton found so far, and it's pretty shitty. And there have been a few impressions as well that are also pretty shitty. And they all seem to indicate an animal at least 8 to 9 centimeters in length, somewhat lizard like with long, thin limbs, and what seemed to be at least six long plume like structures arranged in some way along its back. There was a 2012 study by Michael Butwitz and Sebastian Voigt that strongly suggests that these filaments were soft tissue structures, perhaps supported by follicles at the base, um, but they less strongly suggested that these structures may share a homologous developmental origin with Archosauromorph scutes, scales, and feathers, which incidentally the team also suggests that Archosauromorpha is the possible phylogenetic position of Longus squama. But beyond this, there's little else that can be said about the possible life history of this animal. It was probably arboreal. The structures may be for sexual display or non-offensive defense, but until better fossils are found, it's going to be hard to tell. I do believe that the suggestion or the hypothesis that these filaments are, plant remains that just so happen to be arranged underneath the dead animal, I think that's been pretty much put to bed. The chemical analyses that have been done don't seem to support that these are botanical structures of any sort. But again, that just kind of leaves more questions than answers in this case. The second group are the Wigeltosauridae, which includes four genera of gliding reptiles from the late Permian of Europe and Madagascar. We actually featured one of these guys in our August to September 2022 news
Yep.
episode, Coelurosauravus. Now, another genus, Wigeltosaurus itself, is illustrated on the slide. The gliding membranes of these animals were made of thin, bony rods that radiated from the side of the lower torso, being potentially modified gastralia, and the structures would have been grasped by the forelimbs to aid in gliding, like modern Draco lizards, which this restoration also shows. Now, like Longisquama, Wigeltosaurids would more certainly have been arboreal. I mean, they were gliding animals. And the evidence of the bony structures projecting from their skulls would probably have been display features too. Now, the third group are the Drepanosauromorpha, which have been described as chameleon-like, although to me they kind of remind me of tamanduas,
Mhm.
which are small tree-climbing anteaters, mainly in Central America. Drepanosauromorphs lived during the late Triassic of Europe and North America and include at least 9 genera. We have Megalonchosaurus illustrated here on this slide. They're very bizarre looking reptiles, taking the chameleon approach. Picture a chameleon, but instead of a blocky head and bulging eyes, they have pointed skulls, and in at least some genera, they were toothless. In addition to having a long curling tail, the end was tipped with a pointed spur. Their hands and fingers are also adapted for grasping branches. But in some species, one of the fingers is prehensile
Mhm.
and is tipped with a very sizable claw.
Yep.
And instead of a smoothly horizontal back, like a chameleon, above the shoulders, there was a hump. So, and they would have probably been more anteater like than chameleon like in their habits. There was a 2020 study by Javier Jenkins on several genera that showed evidence for hook and pull abilities for the forelimbs,
Mhm.
and that suggested that at least some of these animals were digging into the soil, or at least into bark, for their food. Now, Center's 2004 phylogeny showed grouped all of these reptiles together, the Wigeltosaurids and Longisquama being sister groups, as avicephala, and they were considered neodiapsid reptiles related to a clade Sauria, which encompasses the common ancestor of all the living reptiles and their descendants, and that's tentatively including turtles into that definition.
Mhm.
Of course, that's another story there. Avicephalans were said to have had shared features like tall scapular blades, as well as lacking features like cervical and dorsal intercentra in the vertebral column. Now, there were later studies that had cast doubt on this arrangement, just for the fact that all these animals were so derived in their morphology.
Yeah.
Perhaps this group may not have been natural, that is, polyphyletic, encompassing animals that do not share a recent common ancestor, but are kind of hooked from all different parts of the family tree. And so this is where Valentine Buffon and colleagues came in. They decided to draw their attention to the skull of a genus of Drepanosauromorph called Avicranium, again with the bird heads here, which was previously reconstructed in 3 dimensions and then used in several recent studies. So they looked at this material and then included it in the largest current sample size of avicephalan genera. So they picked 3 Wigeltosaurids, including Coelurosauravus and Wigeltosaurus, and 6 Trypanosauromorphs, including Megalonchosaurus. Unfortunately, Longisquama could not be included because, again, the fossil material is kind of poo-poo. Um, but again, fingers crossed we find something nice that we can include in the future. But then all of these animals were then included in a fairly large sample across the amniote family tree, synapsids as well as reptiles. They chose 403 characters to analyze, with 297 of these from previous studies, and they were all given equal weight. And so if we jump to the next slide, we can actually see the results of their labor. So I put the actual strict consensus phylogeny here at the top right, but for ease of clarity, I've just created the simplified version here. And the long and short of it is that, yeah, Avicephala is definitely an unnatural group. The Wigeltosaurids and the Drepanosauromorphs show up on different parts of the reptile family tree. The Wigeltosaurids are along the main branch of diapsid reptiles before the clade Sauria evolves, but after several successive diapsid groups emerge. Um, Now, admittedly, the results of the wider tree here were particularly interesting to me. And I guess I was originally out of the loop here in terms of like recent research on fossil reptiles. But apparently, the parareptiles, which have the supposedly ancestral reptile condition of a single temporal opening or fenestra at the back of the skull, are recovered as diapsid reptiles, which ancestry is supposed to have featured the two temporal fenestrae in the back of the skull. Yeah, okay. So I had to do some digging here, and apparently there was a 2020 paper
Yep.
by David P. Ford and Roger B.J. Benson that was the first to recover this results, and there were other studies that recovered similar finds, and occasionally with the parareptiles as an unnatural group to begin with. Um, Now, the new phylogeny in this paper didn't include every parareptile, so maybe this isn't the last word on this. But I thought it was fascinating to consider that we may have to get used to an expanded concept for diapsida. Um, I'd love to get your thoughts on this particular point, buddy.
Yeah, I do remember that paper in 2020 that found parareptiles as diapsids, which is a really intriguing idea because, yeah, it just kind of further emphasizes the recent understanding that um, the kind of the number of temporal fenestrae is not that well correlated with the actual phylogeny. But I would agree that more research is required on that front when it comes to the parareptiles as diapsids idea. I think there's definitely a lot more work that can still be done in that area. But as for the actual focus of this paper, I think this is really interesting because I definitely like these quote unquote avicephalans a lot. I certainly they're probably some of my favorite extinct reptiles that aren't dinosaurs. Um, and they are just so wonderfully weird, and it's no surprise that we've had such a hard time trying to place them. Um, Now, since I'm not really an expert in like the anatomy of these things or anything like that, so I can't really assess like exactly how credible I find this particular phylogeny, but like in broad strokes, I feel like this is probably reasonable. Like these are just such weird creatures that I feel like most positions in within reason in the reptiles would seem like potentially plausible possibilities, and this certainly seems like a very detailed investigation of that. Um, it it is really interesting. The reinterpretation of the avicranium fossil. So that's one of the Drepanosaurs, where they reinterpreted the skull because in the original description of avicranium, I remember this. It was interpreted as having like this toothless beak, kind of similar to a bird, but of course the authors did not. Kind of advocate for any connection to birds because yeah no
Hmm.
but like basically an example of a convergently evolved beak in reptiles, which we know has happened many times. But in this paper, they completely reinterpreted the anatomy of the skull, and they said actually the front of the face is not preserved at all in avicranium, and we only have the back, and so we don't actually know if it had teeth or not. And it's like, oh, well, that's a pretty big change, and it's kind of no wonder you're finding such different phylogenetic results if you're like reinterpreting the anatomy completely differently. It's like yeah, I again I didn't know enough to assess how credible the anatomical reinterpretations are, but I do commend like the effort put into this because such strange taxa that don't have obvious ties to any specific living group just are not easy to place, especially based on morphological data. And I, but I'm very happy that they kind of took this what seems like this very important step forward in studying this question. And I'm always glad to hear more research about these Triassic weirdos, as we sometimes affectionately call them. I would be very interested to see kind of responses from other researchers who study Drepanosaurs in similar forms, because like the authors of the avicranium description, for example, because I know like that was one of the papers that originally that kind of provided support for Drepanosaurs being like non-saurian reptiles, so kind of similar to the position that they find Wigatosaurids here. In the avicranium paper, that's where they suggested Drepanosaurs should go, and I know some previous studies have also suggested that result as well. And so for a while, that seemed like the most supported position for the Drepanosaurs, but now this kind of has renewed support for the Archosauromorph hypothesis for Drepanosaurs, which is kind of like the main kind of alternative view. I think it's a very interesting problem, and again, always glad to see kind of large scale research focusing on these very intriguing taxa that for which we don't have any close modern analogs.
Yeah, just to kind of clarify kind of the results here. Um, so Drepanosauromorphs are recovered as a crocopode archosauromorphs within a clade called Alicotosauria as a sister to the Trilophosaurids, which is another Triassic group of weirdo reptiles that were essentially these big lizard-like herbivores with blunt heads. Um, and this particular result had been suggested in prior studies beforehand, that the ones that were casting doubt on avicephala in the first place. In fact, the authors here stress that they found, quote, unambiguous synapomorphies that united the Drepanosauromorphs with the Archosauromorph group. So I think in terms of this, I think it's pretty that's a pretty solid find for sure. Um, Now, where does this leave us here? Well, again, clearly, avicephala would no longer be in use as a valid scientific term. Um, and some of the proposed synapomorphies that had united these animals in the past would then be convergent traits.
Right.
Though, in fact, according to the authors, perhaps many of these traits were actually just fairly common among Permio-Triassic reptiles, so that they may not be so special as to be convergent, but retained from earlier ancestors. And in a few ways, some aspects of the fossil record would have gotten cleaned up as a result of these studies. I mean, they found that the recovery of Drepanosauromorphs as Archosauromorphs and as a sister to the Trilophosaurids actually reduces the time in the Triassic between the oldest and youngest members of that clade. And so they essentially trimmed down a ghost lineage by 8 million years.
That's cool.
Yeah, which is really impressive. But definitely, yeah, weird enough as they are, these reptiles of this former clade are at least now in some more familiar company. So yeah, I particularly enjoyed this study, and it's nice to see these branches of the reptile family tree filled out some more for sure. But I understand, Albert, with your May study, we're going to leave these sauropsids and hang out with synapsids for just a little bit in your paper.
Yes, we're going to do another mammal study this time, so that's kind of cool. And in fact, it's kind of funny because I know last time we did a news episode, I presented a story about prickly mammals, and well, this time we're going to do another story about prickly mammals, but prickly mammals of a different sort. So this new study is about the origin of the North American porcupine. Whereas the previous story about prickly mammals that we did was on echidnas in Australia. And so these two different groups are like not closely related at all. In fact, they're as distantly related as you can be while both still being mammals. So yeah, echidnas and porcupines not really much to do with each other. They evolved prickliness as a convergent trait. But yeah, let's talk a little bit about porcupines because I think they're quite fascinating animals. In fact, I would say they're some of my favorite mammals, really. This study is specifically about the evolution of the North American porcupine, and that's right off the bat. I think that could sound pretty intriguing to some people because, at least in my experience, I don't know if it's different for you, but I feel like a lot of people who live in the US and Canada do not know that they have porcupines in their region. But they actually do. At least there's a very good chance that they do. Because the North American porcupine, which is the only species of porcupine that is found in northern North America, so north of Mexico, is a very widespread species in North America. So they can be pretty much found all across the United States and Canada, the continental part of it, of course, all the way up north to Alaska. They're amazingly successful species. So porcupines are a type of rodent. And in fact, the North American porcupine is the second largest rodent in North America. The largest is the American beaver. But yeah, porcupines are pretty big. Um, and they don't move very quickly. In fact, they can come across as pretty clumsy sometimes if you ever watch them move around. So you have this really big um, rodent, too big to usually just dig a burrow for itself, and doesn't move very quickly. So you'd think that it basically would be a sitting duck for a lot of predators. Like I'm sure a lot of predators would love to eat porcupine for dinner. What has prevented all the porcupines from being eaten is their very interesting defense, which is their quills or prickles or spines. But usually in technical literature, they're called quills. Um, and these are like some really interesting adaptations. These aren't just like simple spikes in the body of a porcupine that where if you touch them, you'll say ouch, and then you don't want to touch it anymore. Obviously, that is a pretty important way that they work. But porcupine quills are also quite interesting in that they detach from the porcupine very easily. So you can pull quills from a porcupine's body very easily. Um, Now, quills are basically modified hairs, and if you've ever had your hair yanked on or anything, you know how much that can hurt. But it's different for a porcupine. The quills come out very easily, and what this does is that if a predator is foolish enough to just touch a porcupine where it has quills, then a lot of those quills are probably going to detach from the porcupine's body and break off in the body of the predator. So they leave the predator kind of impaled by these quills, and that's pretty nasty. Because say if the predator uses a paw to touch the porcupine, then that means it's going to hurt a lot trying to walk on that paw with all these quills embedded in it. If the predator tried to bite the porcupine, then that's also pretty nasty because now it's got a bunch of quills stuck in its mouth, and that makes eating very difficult. Now, I don't know if you've ever had canker sores or stuff, or wounds in your mouth, but I know just having like a single like wound in your mouth is it hurts a lot. like it's almost like a paper cut on your hand. It's like it's a small wound, but it hurts a lot, and you don't really want to put anything in your mouth near that wound. And so you think about having like a ton of these quills stuck in your mouth. That definitely would ruin your appetite for sure. And not only that, but because the quills often kind of detach inside the body of a predator, the thing is that a lot of these quills actually have like these very microscopic, I guess you could say that they're scales covering them all over their surface. And so these scales kind of stick up a little bit. So they're a little bit like barbs on a fishhook. In many cases, people actually describe the quills of porcupines as being barbed. Depending on how pedantic you are, that's not strictly accurate, but they do have these little sticky up scales on them. And so what this does is that if a quill is embedded inside something like the flesh of a predator, that means that over time, if the quill is not removed, then the quill can travel deeper and deeper and deeper and deeper inside the body of the predator. And that's not very good because what if it hits an internal organ, right? And indeed, people have found like very large predators like mountain lions killed by porcupine quills because of this. Like either they starve to death because they can't get rid of quills in their mouth, or the quills kind of remain in their body until they hit something important, and then that's the end, which is probably not a fun way to go because it's not exactly instantaneous, right? And so as you can imagine, like these quills are a very effective defense for porcupines, considering that they can be lethal even to like big predators like mountain lions and wolves and bears. And so most predators, they have a pretty healthy respect for porcupines. That being said, there are a few North American predators that have been known to prey on porcupines with some regularity. Famously, there is a close relative of weasels called the fisher. A fisher is a close relative of weasels, but it's much bigger. So it's like bigger than a house cat. In fact, locally in some areas, I know people call them fisher cats, which is not a very accurate name because they're not really closely related to cats at all. And furthermore, they don't actually prey on fish all that much either. So fisher in itself is not a great name. But at least fisher by itself is probably less bad than fish or cat because that's doubly inaccurate. But anyways, fishers are well known for being able to hunt porcupines. And the way they do this is that it's actually not that easy for them either. So there are two areas on a North American porcupine that don't have any quills. So one of them is on its underbelly, and one of them is on the face. And so when a porcupine is attacked by a predator, what it often will do is that it will like try to get its face protected. So it'll put its face against a rock or a tree or like in a hole or something, and then present like only the rest of its body to the predator, which is covered in quills. And North American porcupines, again, they're big rodents, so they can outweigh fishers, and the average fisher does not weigh as much as an average porcupine. So if you wanted to turn the porcupine over and attack its belly, that's not going to be an easy thing to do. Some classic sources will say that this is the way fishers try to kill porcupines, but this is not usually what happens. Instead, what the fisher will try to do is try to aim for the porcupine's face. If the porcupine can't protect the face well enough, the fisher will kind of keep biting it in the face until it's too injured to fight back, essentially. And then only then can the fisher kind of try to roll the porcupine over to feed it from its unprotected belly. And some individual mountain lions have also learned to take on North American porcupines, and they seem to do it like kind of similarly too. So of course the mountain lion is much bigger than North American porcupine, so they actually can like turn a porcupine over. And I've heard that in some cases people have observed mountain lions like going after porcupines up in the trees, and so they'll actually like throw porcupines down from the trees and attack them while the porcupine is trying to recover from the fall. So yeah, that's certainly one way to do it. Some mountain lions become like porcupine killing experts essentially, and they'll hunt a lot of porcupines, and they can be pretty effective at that too. But for most part, North American porcupines have done well enough to be like a relatively common species that is very widespread. North American porcupines, since they're the only North American porcupine species, at least north of Mexico, how did they get there anyway? Well, if we want to learn more about that, we have to talk a bit about what type of rodent porcupines are. Porcupines belong to a group of rodents called it's either called Hystricognatha or Tinohystrica, depending on who you ask. But the general idea is that these are the porcupine-shaped rodents. Now, this group of rodents, or at least a large portion of them, appear to have originated in Africa. And indeed, in Africa today, there are also types of porcupines there. But the kind of twist in the tale is that African porcupines, and as well as Asian porcupines, so the Afro-Eurasian porcupines, are not that close to our American porcupines. No. So even though they're both members of this Tinohystrica group, they do not form a group that is just them and no other Tinohystrican rodents. So they are like completely separate lineages within Tinohystrica here. Now, if you're wondering what the other big lineages of rodents are, so there's also like a squirrel-related group of rodents and a mouse-related lineage of rodents. So you can kind of think of rodents as these three big main lineages. So like the porcupine-like ones, the mouse-like ones, and the squirrel-like ones. So both American porcupines and Afro-Eurasian porcupines belong to this porcupine-like group, but they're like separate lineages inside this group. Now, what are some other like porcupine-like rodents? Well, the African mole rats are members of this group. So if you've ever heard of the naked mole rat, well, yeah, that's one of these porcupine-like rodents. And so like Afro-Eurasian porcupines, the African mole rats are also found in Africa. But at one point, probably early in the Cenozoic, one lineage of these African Tinohystrican rodents made a big journey across the ocean, across the Atlantic Ocean, to South America. How did this happen? Well, the leading hypothesis is that they probably got there on some kind of raft. So like a big mass of vegetation got washed out to sea, probably carrying these rodents with it. By luck, it managed to wash out onto the shores of South America, where fortunately these rodents were still alive, maybe barely, but alive. And from there, they were able to diversify into a great variety of forms. And that sounds pretty far-fetched, but it is the best hypothesis that we have for how these rodents got to the Americas. And we have talked about this hypothesis before, but in relation to monkeys. How did monkeys get to South America? Probably something similar happened, at least that's what we think. And there is actually a group of birds that might have done this too. So there's a species of bird called the Hoatzin, which is only found in the American tropics today. It is not very good at flying, but we have found closely related forms as fossils in Africa, and it is also suspected that they might have made this journey too. And it sounds pretty far-fetched. But again, this is the kind of thing that it only had to happen once for it to work, essentially. And given a long enough period of time, especially at a time when the Atlantic Ocean was a bit smaller, who's to say that it couldn't happen? We certainly don't have any better ideas for how to explain the distribution of these animals. And we do know that animals can get washed out to sea on these big masses of vegetation, and they sometimes can end up on other islands. People have seen it happen, like with iguanas and such. So again, it only had to happen once successfully, and theoretically, it could have happened with like a single pregnant female on board the raft. It would take a lot of time, maybe, for all the kind of chance elements to fall into the right place, but it definitely can theoretically happen. In any case, once the porcupine-like rodents got into South America, they kind of diversified rapidly, and you probably heard of many groups of these porcupine-like American rodents. So think about capybaras, think about guinea pigs, which a lot of people keep as pets now. Think about chinchillas. So all of these are descendants of those first porcupine-like rodents to have gone over the ocean to South America. And they are crazy diverse. And among these were also the American porcupines. Now, even though there's only one porcupine species that gets up north of Mexico, there are actually a bunch of others that still live in the American tropics. And most of these, like tropical American porcupines, differ from the North American porcupine. Most of them are smaller. In fact, pretty much all of them are smaller, I would say. And notably, most of them have a long prehensile tail, which is really cool. You can see a comparison of a tropical American porcupine with the North American porcupine on the slide here. So notice that the North American porcupine has a very short, stumpy tail, whereas the tropical American porcupine, specifically a streaked dwarf porcupine, has a very long tail, and in fact it is prehensile. It can grab onto branches and such. And so the American porcupines, they actually spend a lot of time in the trees. And I feel like in a stereotypical kind of idea of a porcupine that most people have, you don't really think of porcupines as being kind of tree climbers, right? In fact, I feel like the general idea that many people have of a porcupine and probably more closely resembles Afro-Eurasian porcupines, which do spend most of their time on the ground. But in fact, our American porcupines are mostly tree climbers, and they spend a lot of time in the trees, especially the tropical American ones with that prehensile tail. The North American porcupine, even though it is also a tree climber, you can tell in the picture, it no longer has that prehensile tail, but it does also spend quite a bit of time in the trees, and it spends a lot of time in trees feeding on things like tree bark and pine needles and such. So it has kind of retained this kind of tree-dwelling habit from its South American ancestors. But how did it get to North America? Well, that's something that happened kind of later in the Cenozoic. So during what we call the Great American Biotic Interchange, and we have actually talked about this event before on the show, specifically in Dinosaurs, the second chapter, when we were talking about terror birds, because this was another group of animals that participated in the Great American Biotic Interchange. And what this is basically the formation of the Isthmus of Panama, so some of the land that forms Central America today. Kind of when it formed, it created this land connection between North and South America. And so animals that were formerly restricted to the north were able to move down into South America, and animals that were formerly restricted to South America were able to move north into North America. And porcupines were one of the groups that moved north. And so that is how we finally got our North American porcupine. Most of the North American Great American Biotic Interchange probably happened sometime in the Pliocene. That seems to be what the fossil record shows us, although we know that some of these kind of crossing over events were already happening in the Miocene as well, in the late Miocene. So this period of time when we had this like interesting exchange of organisms going back and forth, north and south. So we have a pretty good understanding of like, the evolutionary history of how the North American porcupine got to North America, but we don't really know much about like when and why its distinctive features from the tropical American species evolved. So why did it have that short tail, and when did it get that short tail? Well, that's something that this new study that we're going to talk about helps us understand better. So this new study, what the authors did was that they present a new specimen of an extinct species of porcupine found in Florida, the Pleistocene of Florida. So that's a pretty recent time in geologic terms. In fact, there probably would have already been North American porcupines around at this time as well. Now, this extinct species of porcupine is classified in the same genus as the North American porcupine, so the genus Erethizon, but it is a different species, so it is Erethizon poyeri. Previously, Erethizon poyeri was only known from some incomplete remains of the head of the skull, so we did not really know what the rest of its body looked like. However, with this nearly complete specimen, we have nearly all the skeleton, and you can see a picture on the slide here. So we have like pretty much all the important parts, really. Like we have most of the limbs, we have much of the tail, and we have another skull to go with it. So what does this show? It turns out that Erethizon poyeri from the Pleistocene of Florida has a long prehensile tail, a lot like the tropical American porcupines do. Furthermore, it also has hind feet that are more adapted to grasping, so they can like kind of encircle a branch with its hind foot alone. Whereas the North American porcupine, even though it can climb, it's not so good at grasping with the hind feet. And furthermore, Erethizon poyeri also exhibits some differences in the skull from the North American porcupine. The incisors, which of course in all rodents are very prominent, and ever growing, are less robust in Erethizon poyeri compared to Erethizon dorsatum, which is a North American porcupine. What does this mean? Well, this might suggest that Erethizon poyeri was not as good at feeding on things like very, very rough or hard food items such as tree bark compared to the North American porcupine. It might have been more like the tropical American porcupines, which feed on softer vegetation, such as fruits and flowers and buds and leaves. And the North American porcupine likes to eat all of these things too, but it has like these increased specializations for feeding on bark, which is very useful because the North American porcupine does not hibernate. So it has to endure these really cold winters all the time when there's hardly any green vegetation to eat. And remember that these guys can be found as far north as Alaska. So like these are really cold winters we're talking about. But because North American porcupine has these adaptations for feeding on bark and pine needles, it is able to survive in like these huge variety of environments and climates. So what does this tell us? Well, what this tells us is that even until very recently, very close relatives of the North American porcupine that were found north of Mexico had features that were very similar to the neotropical porcupines. They had a long prehensile tail and grasping feet and teeth that are better built for softer vegetation. And so the origin of like the interesting traits in the North American porcupine are like very specific to it. So like even its very close extinct relatives don't have these features. And probably they originated like relatively recently, but probably it is also these same features that has helped it become such a successful species in the modern day. Now, why might the North American porcupine have lost that prehensile tail? You'd think a prehensile tail is very useful for a tree climbing animal, right? And in fact, we know that the North American porcupine today, even though it can climb trees, it often falls out of trees, like even without mountain lions throwing them out of it. So that's something that seems kind of inconvenient, right? And we do know that porcupines can get pretty injured from these falls. So why not have a prehensile tail that can help act as a fifth limb to grab onto branches and stop you from falling out of trees? Well, one possibility is maybe the North American porcupine needs to get around more on the ground. So maybe having a long tail dragging behind you is not so convenient when you have to walk around more. And that's certainly a possibility. But the truth is that we don't really know for sure whether or not the North American porcupine spends less time in trees than the neotropical porcupines do. These animals are pretty hard to observe in the wild, especially the neotropical porcupines, because they're pretty nocturnal and pretty shy, and they often spend a lot of time like way high up in the tree canopy. So they're hard to observe in the field. In fact, gosh, it was really difficult to find an image, a photo that I was allowed to use of a tree porcupine, a neotropical porcupine, um, that actually showed off the prehensile tail very well and actually showed it in like a natural looking environment. Yeah, I actually had spent a lot of time trying to find like a Creative Commons photo for this. It's you wouldn't believe. But anyways, um, having that long prehensile tail might get in the way of getting around on the ground, but um, the truth is that we do sometimes see neotropical porcupines on the ground too. It's not like they never come to the ground or anything like that. And we do know that the North American porcupine spends a lot of time in trees, so whether or not this makes a significant difference is unclear. It may be that the North American porcupine has to travel more between trees because the forests in North America might be not as dense as like in the tropics. So maybe it has to come down and travel to other trees more often, and therefore it can't have depend on a prehensile tail for doing that. But yeah, again, like a lot of these ideas are pretty untested. I think one other idea has quite a bit of merit to it. Is maybe it's for thermoregulation, because having this long, skinny appendage can be very useful if you live in the trees in the tropics, but it can be a big liability. When you live in a colder climate, because that's like this very long appendage, often with like very little or no hair on it, because in a prehensile-tailed porcupine the tail is not covered in quills, because it needs to be used for grasping, right? That means that if it gets really cold, you're losing a lot of heat from that long tail, and so maybe in the North American porcupine it's an adaptation for colder climates where they reduce the length of that tail so it doesn't lose as much heat. And I think there's a pretty good merit to this because in Virginia opossums, which are another species of mammal that descended from South American ancestors that came up into North America, opossums have been gradually shifting their range north over the years, but they can't get too far north. And one of the reasons for that is because they often suffer from frostbite on their tail. And Virginia opossums, they're a type of marsupial, so they're not closely related to porcupines, but they have this very similar kind of evolutionary history, right? And they also have this prehensile tail. And the thing is that they often get frostbite on the tail when it gets too cold for them. Sometimes in the wild, in opossum populations that are found very far north, you can find individuals where they have lost a tail to frostbite. And well, that's not very good. So this may be a very like strong adaptive advantage in kind of the northern reaches of the range of the North American porcupine. One possibility that is not mentioned by the authors is defense, because the North American porcupine's tail, even though it's very short, actually has a pretty important function. I mentioned earlier how these porcupines defend themselves, right? And the thing is, like, when a porcupine is defending itself, it's often not just like sitting there and just presenting its spikes to the predator and waiting for the predator to come and attack it, just on the off chance that it might get spiked. The porcupine actually will also use an active defense, is that the North American porcupine will use a tail as a weapon, basically. So it'll like swing its tail from side to side. So if the predator comes too close, it's going to get hit by that tail, and that tail is covered in quills in the North American species, and so it's going to get impaled by the quills. And so, yeah, I wonder if in some way, like the North American porcupine might be, might have to contend with large predators more often or things like that, and might require this as a weapon. I don't know. I do think the thermal regulation idea has a lot of merit to it. Maybe the kind of more terrestrial habits have something to do with it, but I am intrigued by the defense possibility. That's like something we know North American porcupines use a tail for. Something else I'll add while we're here is that porcupines do not shoot their quills. They cannot like fire their quills from their skin, like firing an arrow or something. The quills come off very easily, but you have to like have gotten stuck by the quills first before they come out. They can't just fire them from a distance. And the last thing I'll mention is that, as you can see, there are quite a few misconceptions about porcupines. We mentioned that they don't have much to do with echidnas. They also do not have much to do with hedgehogs. Hedgehogs are not rodents. They are closely related to moles and shrews, which are also not rodents. For some perspective, you and I are more closely related to a porcupine than a porcupine is to a hedgehog. So yeah, like rodents and primates like us are closer relatives to each other than we are to like the mole and shrew and hedgehog group. Just some food for thought there when you're thinking about prickly mammals. Yes. There are a lot of fascinating things I could say about porcupines, but I think that just about covers the main points of the paper. Do you have anything to add to this?
Well, I think that was a very good introduction to porcupine biology. especially for the American porcupines. Living in eastern North Carolina, where I do, we don't get porcupines,
Hmm.
and that kind of bugs me
Yeah.
because I feel like it'd be a really cool thing to see out
Right.
in the wild. So I've seen footage of porcupines, of course, especially of our American variety,
Yeah.
and it certainly would be a sight that would make anybody pause around here.
Yep.
They think it like that's a weird nutria walking
Yeah.
around,
Right.
or something like that. Um, but no, I'm really happy to see this paper because, as you said, we had fossils of this animal before, but it was very like fragmentary remains. Now we got a really nice looking skeleton here. It looks like, and it's showing almost sort of transitional stage
Yep.
towards our modern North American porcupines from the South American varieties, which I guess thinking about it from like a phylogenetic perspective, like it makes a lot of sense that this is how it would have been.
Yeah.
So to kind of have the fossil evidence now to support that
Mhm.
is extra nice. I love it when you have multiple points that converge
Right.
to explain the phenomena in nature, such as this. So it's really cool to see. Um, I'm very curious as to like what other biology we can find out about poyeri here.
Right.
Like was it doing much the same thing that porcupines do today in North and South America? Um, what kind of prey interactions or what kind of interactions were going on
Mhm.
between the animals and its environment? What kind of foods was it eating? Because Pleistocene Florida is a fascinating locality. I When I went to the Museum of Natural History there
Mm.
in Gainesville, I don't believe I saw anything about this species of
Mhm.
porcupine.
Mhm.
So I don't know, maybe the next time I'm down there and they decide to update their
Yeah.
paleontology exhibit, maybe I'll see a cast of the specimen or the specimen itself. I don't know where it's housed right now, um, but it adds another nice piece of the puzzle to Florida's fascinating history. Um, I think we joke a lot about Florida as a state today, but I think in terms of like deep history, like there's some really fascinating things that were happening
Yeah.
there. We could do a whole lecture series on the deep time of Florida, and I think that would be pretty successful. Um, of course, I say that about a lot of subjects on the
Yeah.
show.
Right. Right.
Um, this is a really great paper, fascinating. It's a lovely fossil. I like this graphic here showing all the bones laid out. Um, I wouldn't be surprised if you took you filled in the gaps a little bit with data from the living porcupines. You can make a pretty good skeletal
Yeah.
reconstruction of this animal.
That's true.
That would be kind of neat to see. Too bad the quills don't seem to preserve
No. Mm.
in these fossils, do they?
Yep.
Because it's hair,
Yep.
and good luck finding hair in the fossil record.
Yeah. You can sometimes, but it's very rare. Not in conditions like this. Yeah.
Yeah, we need a Florida Lagerstätten
Exactly.
one of these things can fall into. Um, that's wonderful. Thank you so much for sharing
Of
this.
course.
It's neat to see, and I think with that, that's it for our news episodes today.
That's right.
Well, it's a fascinating selection of papers, and we're glad you all could join us to hear about these discoveries for the past couple of months. Um, Honestly, like given the time that we had since we last aired a news episode, the pressure of finding stories is a little bit higher in these instances because instead of finding two cool papers for 1 month, we're finding one cool paper for you know for each month.
Right.
And I know there were certainly plenty of other papers I could have chosen, but I'm pretty happy with these.
Mhm.
In fact, I think when I found out about the First Nations paper and the avicephala paper, I immediately was like, I got to talk about these now. So I think I had these like for like almost like I think it was like mid May
Yeah.
that I had everything figured out for this.
That's great.
So like I was pretty set. I'm like, yes, these are the ones. Um, yeah, hopefully we can make our schedule more regular again and go from there. But yeah, that's it for Through Time and Clades. Let's go now to our usual acknowledgments and post news stuff. So We are on Patreon, of course. That's patreon.com/timandclades. Patreon is a service where, for any small amount of donations that you add, you'll get access to kind of exclusive content and follow up with us as we produce our series. Any donation is acceptable, and your contributions, of course, would help us continue this series and develop new projects and expansions. Um, and of course, Patreon supports a tier system where we have certain amounts that you can choose to donate to, and you'll get perks with each successive tier. And so in this instance, we have people on a tier list where they are owed shout outs at the end of each episode. So I want to thank my sister Julie and our friends Paul, Denver, Tristan, Frankish, and Valdinunzio for their contributions. We really appreciate your support, and we're always happy to see you all around. Moving on to the next slide, of course, our general acknowledgments. I'd like to thank our good friends Henry and Alicia for their contributions to this series. Henry, of course, is responsible for the wonderful theme music that opens each episode, and Alicia is responsible for the color scheme of Albert's Allosaur avatar, cheery little fellow. Of course, moving on, we are, yes, still on Twitter. We are at Time and Clades, where we generally upload the episodes as they are finished. Of course, we're also on YouTube. That is through Time and Clades, where you're most likely watching us. So if you're interested in liking, subscribing, and following, we always appreciate that. If you have any questions at all about this show, whether about the topics we've talked about on the show or just anything in general, there's three ways to contact us. You can send us an email, timeandclades@gmail.com. You can tweet at us, or you can leave a comment in our YouTube section, and we will respond to those in kind. Now, if you want to access the papers that we've talked about today and anything else that we've mentioned regarding the announcements for the paleo documentaries or anything like that, you can go to our description where we put links to references for this episode. But with that, that's it for Through Time and Clades. Yeah, in terms of what to expect next, fingers crossed, knock on wood, all that jazz. Hopefully, we'll have a regular news episode in July covering our June stories. Best case scenario. And I will do my best to continue work on Humanity a Prologue Season 2. I cannot make any promises right now, but I'm already kind of made a lot of progress on episode 2 anyway, so it wouldn't take hypothetically a lot for me to start it again. But when I do, we will be sure to let you all know. But otherwise, that's it for us. Thank you all so much for joining us today, and we hope you have a wonderful rest of your time.
Absolutely. Take care, everybody.